All right, so in this video we're going to be looking at Lesson 1.1. Now Lesson 1.1 is just going to cover some basics of statistics. We're going to be looking at some different types of tables and graphs, but to start out with we're going to learn about some different terms and different variables here. Now just as a side note, remember you can print out these notes on Schoology, so you can have the exact same thing that I'm writing on. You can have that in front of you as you follow along. Now if you choose not to do that, you still need to be taking notes. Now, sometimes it can be a challenge to know what you should write down and what you shouldn't. And so what I usually do is I try to highlight the very important stuff. Like here we see a couple of terms. Those would be the things. Now, there's other terms that are listed as well with statistics and a variable. Not to say that those aren't important, but the other two terms, population and sample, are going to be two terms that we're going to be using regularly, and you're going to see a lot of questions on in your homework, quizzes, and on your test. So let's go ahead and get started. So just a basic, obviously this course is called Functions, Statistics, and Trigonometry. So one of the key pillars of this course is going to be statistics. And so a lot of this first semester is going to be focusing on this concept. So what are statistics? Well, statistics is the science of the collection, organization, analysis, and interpretation of data. And it's also a number used to describe a set of numbers. So we're going to be looking at different types of statistics as we go through this course. Now, in algebra, we're familiar with variables like x and y. Now, when we're dealing with a statistic, or when we're dealing with statistics, a variable in statistics can be a number of things. It can be a characteristic of a person or thing that can be classified, it can be counted, it can be ordered or measured. So some different examples of variables that we could look at are gender, height, and age. Now, just as a side note, you see the blue lines underneath that. That's just because when I'm using this, I'm using Microsoft Word. And Microsoft Word will underline in blue anytime that there might be some kind of grammatical issue. So the fact that I have a dash followed by a couple of spaces there, they're saying, oh, what's going on here? You might want to correct that. So just know, oh, why does he have that underline in blue? That's not me. That is Microsoft Word doing that to just say that there's a grammatical issue that they think is an issue, that they think there's a problem there. But there isn't. So don't worry about those blue lines. All right, let's talk about a population and a sample. So when we talk about a population, we're referring to the set of all the individuals or objects you want to study, versus a sample is a subset of the population. So what does that mean as far as how can we look at that? Well, let's just look at a school, for example. And the amount of seniors in an entire school would be the population of that study. Now, a sample of that could be maybe you just look at the seniors, and let's say if I'm trying to make a study about the seniors in Edina High School and their viewpoint on a certain topic. Well, I may not have time to interview every single senior in the school. So maybe I just interview the seniors that I see in my classrooms. So that would be a sample of the population of seniors. Or maybe we're looking at all the seniors in the United States. Well, if I'm just looking at the seniors in Edina High School, that is not the population of all the senior students in the United States. That is a sample. So that is the difference between a population and a sample. So population would be everything you're trying to study, and a sample would be a subset of that population, if that makes sense. Because there are times where we can't study the entire population. For example, we're going into an election, obviously, this year, a very important election. And we're not going to know what the population thinks or their viewpoint until the actual election day with those that vote. And so they're going to be doing different surveys and polls of people. And so those pollings represent a sample. Because that would be a subset of the entire population. So that is a difference between the two sets there. All right, so just to see if you can understand the difference between a sample and a population, I want you to look at this example. Here it says, a medical laboratory technician draws 10 milliliters of blood in order to determine the number of white blood cells in a patient's bloodstream. I want you to identify in this scenario what the variable would be. So what are you studying? What's the population and what's the sample? So take a minute, go ahead and pause the video and see if you can figure out what those three things are that I've highlighted there in purple, green, and red. So I'm hiding the answers. So I want you guys to see if you can figure out the answers yourself. So pause the video, see if you can figure that out, and hit play when you're ready to check to see if you've done it correctly. All right, let's look at the variable. So did you identify the variable in this situation? The variable in this situation is the number of white blood cells. That is what we are studying. So the population in this situation would be the patient's blood. Okay, so all of the blood in the patient would be the population. Now, obviously, we can't study all of the blood in the patient's bloodstream, and so we're going to look at the sample as being the 10 milliliters of blood that they take out. All right, so that's what a population and sample and what's a variable is all about. All right, so in this course, we're going to be looking at a lot of different tables. We're going to look at sets of data, and that data can be represented in tables and in graphs. And so here we have a table that's looking at a survey that was done, looking at all the different protective gear worn by inline skaters in the city of Boston. So we get that from the paragraph on the left. It says in Boston, 2,145 selected inline skaters were chosen for a survey and asked to classify their ability as beginner, average, or advanced. They were also asked whether they wore protective gear like helmets, knee pads, shin pads, and elbow pads when skating. And then we have all that information gathered in this table. So I want you to take a few minutes to answer these questions. Whoops, gone too far. So I want you to see if you can answer these questions based on that table. So I want you to figure out, is the data based on a sample or an entire population? What are the variables that are represented? What percent of skaters wore no gear? What percent of beginners wore no gear? And how many skaters said they were advanced, and how many advanced skaters wore gear? So I want you guys to do your best to answer those questions, because this is all just, these questions are just based on, do you understand how to read a table? So I want you guys to go ahead and pause the video and hit play when you're ready to check to see if you've got these 6 answers figured out. All right, let's see how you did here. Did you get these answers correct? So first off, it says, are the data based on a sample or the entire population? So for this, you got to remember that they only surveyed 2,145 people in Boston that were inline skaters. That doesn't necessarily represent all of the inline skaters in Boston or even around the country. So that is just a sample that they did. What variables are presented? Now, there is not 5 variables or even 4 variables. Okay, so the 2 variables are what skill level were they? And then the second variable is the gear that they wore. Okay, so however you wanted to phrase that. Because if you think about, sometimes you just need to think about how was the survey presented. So they probably asked a question, how would you gauge your skill level? And then they were asked another question of, how much protective gear do you wear? And then they use that information to break it up into this table. So then when they asked in part C, what percent of skaters wore no gear? So if you think about, so what I boxed up there in blue, we know, so this is dealing with the total number of people. So what percent of skaters wore no gear? So out of 2,145 skaters that they surveyed, 874 said that they didn't wear any gear. So that would be, as a decimal, that would be 0.407, which as a percent, which is what they're looking for. Now you could have said 40.7%, or you could have rounded up to 41%. I would accept either answer. So in that part D, when it says what percent of beginners wore no gear, okay, so now we're focusing on just those that said that they were beginners. And there were 709 people that said that they were beginners, and out of those 709, there were 188 that said that they wore no gear. So there was less, so about 27%. There was a smaller percentage of beginners that wore no gear versus all the skaters in general. And part E, how many skaters said they were advanced? Well, that's just looking at the table and saying that there's 754 skaters that were advanced. And part F, how many advanced skaters wore no gear? Well, if you add up the 242 and, how many advanced skaters wore gear? If you add up the number of people that wore 1 piece and those that wore 2 to 4 pieces, there were 384 skaters that wore gear. Now, those types of variables, so those variables that we just looked at, can be put into 2 different categories. You want to make sure you understand these 2 categories. Variables could be called categorical variables, and they could also be called numerical variables. Now let's just take a second to think about what those represent. Categorical variables are variables where the values do not correspond to a specific number. So your response is going to be like the gender, okay, male, female, or other. Eye color would be an example of a categorical variable where you could have blue eyes, green eyes, brown eyes. So anytime you give a response that would not be a number would be a categorical variable. Now, if your response is a numerical response, that's where we would have a numerical variable. So looking back at these 2 different variables were skill level and protective gear. So the skill level would be a categorical response because you're not responding with a number. However, protective gear would be a numerical variable because you're giving a number as an answer. So if I ask you how much gear do you wear when you go rollerblading, you would respond with a number saying, well, I don't wear anything, so that would be 0. Oh, I wear knee pads and a helmet, so that would be 2 pieces. So that is going to be a numerical variable. So now we're going to be looking at different graphs in this unit. One of those graphs would be a traditional bar graph. Now you've seen bar graphs before. Now a bar graph compares categorical variables with a numerical variable. So here's an example of that, where along the bottom there, along the x-axis, you would have your categorical variable, which would be your household education level. And on the side there, you have the income, how much money people make based on the amount of education that people got. Now, it's also important to, when you're reading a graph, to make sure that it's very descriptive. You should be able to look at that graph and be able to know everything about it. So if you notice across the top there, we have a title. The title is not something simple. It's pretty descriptive. It's an entire sentence, basically, where it's telling us that this graph represents the median income of households by level of education of head of household in the year 2005. Okay, so that is all important information. We see that the axes there also give us important information. We can see there that the left side is the income, and it's based on thousands of dollars. So that 20 does not represent $20. That means that that person makes $20,000 in that category. The scale is consistent. So you can see on the left-hand scale there, they're counting by 10,000s. Now they didn't want to squeeze in a whole bunch of numbers, so they put every other one there. So each horizontal line there represent $10,000, but we only see the 20, the 40, the 60, the 80, and $100,000 listed there. And you also have spaces between the bars in a bar graph. That's traditionally the best way to do it. If you don't have spaces between the bars, that usually is going to indicate that we're dealing with a histogram, and that's a different type of graph. Now here we have another type of graph. This is going to be a stacked percentage. So when you're this would be a stacked bar graph. And the way that they organize these is, so this is looking at that table with all the different gear that people wore. They just transferred this into this graph. And you can see that looking at those numbers really didn't tell us a whole lot, where here I can look at this and I can draw out some better conclusions. Like you can see what percent wore 2 to 4 pieces in each of these different categories. And you can see, again, each of those different pieces of information. So I would take a minute to look at that. You're going to have questions in your assignment that's going to ask you questions based on this graph, but you'll see the same graph in your homework or in your assignment for this lesson. All right, so let's end this video. I want you to look at this example. Now there's a lot of information here. So basically what this is doing is this is looking at the education, the highest level of education completed by a householder. So you can see that in the far left column. And then we have the number of households that had each of those level of education. And then you can see the income. Okay, what percent of people fell into those different income brackets. All right, so as we look here, so I'm going to scroll down here. So if you want to pause the video after looking at these questions, this is where having these notes printed out makes it a lot easier to follow along. But I want you to take a minute to answer these different questions. So there's a total of through F. So if you don't have my notes, you want to make sure you pause this so you can see all these. Now the only one that you don't have to respond to, I forgot to take this out, is you don't have to worry about part B here. So I just want you to do A, C, D, E, and F. And I believe in the notes that you have, I think I might have already taken out part B. But if I didn't, don't worry about part B there. So go ahead, pause the video, answer all of these questions, and then hit play when you're ready to check to see if you've done them all correctly. All right, let's see how you did. So first off, the two variables is you're looking at the highest level of education completed. And so that would be a categorical variable. And the second variable would be the income. Now you might be looking at, well, there's a lot of different answers. Well, or in that table. Well, you got to, again, put yourselves in the shoes of the person either writing the questions or responding to questions, and how would they came up with those numbers? Because you might say, well, what about the median income? Well, again, they'd be asking someone, how much money do you make annually? And so someone will be give a number as a response. And what they did is they took those numbers and they put them into different categories as far as what distribution are they in and what was the median income. And we're going to learn about what that term means in the next video. So there's only two variables in this situation, the highest level of education and the income. And the highest level of education, again, would be categorical. The income would be numerical. All right, the next question there, part C, it says, interpret the table entry 31,153 in a sentence describing its context. Now, notice my answer here. 31,153 is each of these numbers in the table. If you look at the top here, each of those numbers represent thousands of people. So really what that means is that you need to add 3 more zeros after each of those numbers. It's just that they didn't want to squeeze those numbers into the table like that. And so they reduced them and then just said, well, these represents thousands of people. So the 31,153 represents 31,153,000 people or households. So in those households, the householder had a bachelor's degree or higher. And part D, now there's a lot of statements you could have made, but this would be probably the most common response would be something along the lines of saying that the higher the education level, the greater the median income. All right, so this would be where we get work with some math here. So part E, it says, how many times as likely was a family to have an income of at least $100,000 if the head of household had graduated college rather than not started high school? So what you do is you would take those two numbers, the 36.2 and divide it by 2.2, figure out how many times larger and more likely you are to have that happen, and you get about 16.5 times more likely there. And lastly, how many times more likely was a family to have an income of less than $15,000 if the head of household had some high school but no diploma rather than graduating from high school? So if you add those numbers together, you had to do a little bit of math there on the front end. You'd get 30.1 versus 16.6. So when you divide those out, you get about 1.8, or you could even round it to say about 2 times more likely. Well, how'd you do? I hope you did well and were able to interpret those graphs, and hopefully you have a better understanding of some of those terminology, especially with populations and samples and numerical variables and categorical variables. But with that, that is the end of these notes, so make sure that you took good notes and come to class prepared with any questions that you have.